Bismillahir Rahmanir Rahim. Here you can see that I have given you the distance time graph or displacement time graph, and here it is speed time graph or the velocity time graph. I have already told you that while discussing the graphs, there may be not too much differences between them. Okay, well, first of all, here you can see I'm going to compare these two graphs. Okay, so here while comparing these two graphs, you can see that if this line in the distance time graph, distance is along y-axis and time is along x-axis. Now here this line, which is starting from the origin, starting from zero, if it is something like this, this is showing that the body is at rest in the case of distance time graph. The same is the case, body is at rest, it means zero velocity. This is also showing that the body is at rest. Now come to the second point here. This line is also showing that the body is at rest. In the case of distance time graph, here it is zero distance, here there will be some value of distance. So after covering this much distance from the given destination, or the distance covered after covering this distance, the body has come to at rest. So this is also showing that the body has rest. But in the case of velocity time graph, this is not showing that the body is at rest. This is showing that the body is moving with uniform velocity or constant velocity. That value of the constant velocity can be read from this point. Here, the value of the velocity may be given. As you know that the horizontal line is showing that the gradient of the graph is zero. As I told you that the gradient of velocity time graph gives you the acceleration, and the gradient of the distance time graph gives you the speed. Remember these two things. Okay, so here you can see that the gradient is zero in these two cases. It means the speed is zero because these two horizontal lines have gradient zero. This horizontal line is showing that the velocity is zero, so there is no question for acceleration. Now this horizontal line is showing that the body is moving with uniform velocity, which is showing that acceleration is zero. Now come to page number 2. In the page number 2, I have shown you that the constant speed, this is distance time graph. The constant speed will be shown with the help of this type of line. It is showing that the body is moving with a constant speed. But in the case of velocity time graph or speed time graph, this line is showing the increasing speed. The increasing speed is shown with the help of this line. Now again, here I have given you the comparison of two speeds. These two lines have different speeds. Here the gradient is lesser, so this speed will be lesser. Here this line is more steeper, so here you can see that the speed will be greater. So speed B will be greater than speed A in this case. As you know that in the velocity time graph, the gradient is telling you the acceleration. Here, this is the acceleration A1 and this is acceleration A2. Obviously, this A2 is more steeper, so acceleration A2 will be greater than acceleration A1. Now, come to the next page. Now, here in distance time graph, the direction of travel is opposite. This line is showing that wherever the body has reached, from that point, the body is coming back to its original position. This is the original position, mean the distance zero. It means started from here and the covering this distance, and after covering distance, the body is coming back. So this is showing that the distance is traveled in the opposite direction. Okay, so the gradient of this line is also showing that there is the speed of the body can be shown with this line. Actually, as you know that when the line is just like this, its gradient is negative. That negative sign will show you that the body is traveling in opposite direction. Okay, now here this line in the velocity time graph, this line is showing that the gradient is negative mean there is deceleration or negative acceleration, mean minus acceleration or deceleration, as you already aware of it. Okay, now I have made an example for both the graphs. This is an example of distance time graph, and this is an example of speed time graph or velocity time graph. Now here you can see that the body is starting from from A to B. A to B, it means the gradient or the slope of this line can give you the speed of the body. I have made here home till shop. It means from home, the body or is moving to shop 20-meter distance, and this will be the speed of the body. So you can find out the speed of the body by this by dividing 20 meter by 5. So the speed at AB will be 20 divided by 5 is equal to 4 meter per second. This will be the speed from A to B. Now here from B to C, the line has become horizontal. As I told you that the gradient of the horizontal line is 0. It means here speed is equal to 0. Now from C to D, the body is coming back to home. Okay, it is coming back to home. So this is the gradient of the line which is showing the speed when the body is coming back to home. The distance traveled is 20, because from 20 to 0, obviously the distance traveled is 20, and the time taken is 10 seconds. 20 by 10 is equal to 2 meters per second. So here you can see that the speed for the back journey is 2 meter per second, and speed for the forward journey was 4 meter per second. So this was about the distance time graph. But same shape I have made for the velocity time graph. You can see that from 0 at 0 from A to B, the gradient of this line will give you the acceleration. It means the velocity is increasing at a constant rate. Velocity is increasing at a constant rate, and it reaches at 40 meter per second. Okay, so from A to B, if you are asked that what is the acceleration from A to B, then change in velocity divided by time. Change in velocity from 0 to 40 is 40 divided by time 5. So 5 eights are 48 meter per second square will be the acceleration. Acceleration during A to B. Now acceleration here, as I told you that the gradient of the horizontal line of velocity time graph gives you the acceleration. So here horizontal line acceleration 0, because gradient is 0. Now from C to D, the velocity is decreasing. Okay, so initially its velocity was 40 meter per second. From here, the velocity is decreasing to 0 at 25th second. This time is given in second, and the velocity is given in meter per second. So you can write that 0 minus 40 over the change in time, 25 minus 15, 25 minus 15. So the answer will be for the acceleration will be minus 40 over 10. So here you can see that the acceleration is minus 4 meter per second square. This will be the acceleration which is negative acceleration. I told you that this negative acceleration is called retardation or deceleration. Because in this section the final velocity is 0. This 25 is for the time. At 25th second the final velocity has become 0. Okay, so that is why the final velocity, which is 0, minus the initial velocity. This is the initial velocity for the last part of the journey from C to D, because I am taking this portion from C to D. So here the initial velocity was 40 and the final velocity at 25th second become 0 to 0 minus 40 over the time interval 25 minus 15. So I calculated this acceleration is minus 4 meter per second square. I told you that the negative acceleration is called deceleration or retardation. Okay. Please listen to me again, that in the case of distance time graph, if the negative sign comes in the calculation when there is a backward journey, so this negative sign shows that the body is coming back to its original position. I think so you better understand this, because it is a backward journey. For the forward journey there will be a positive sign, there will not be a negative sign. But when it is coming back towards this previous position, then there will be a negative sign which is showing that it is a backward journey. Okay. But in the case of velocity time graph, when the negative sign comes, this negative sign shows that this is a deceleration. One student is getting confused regarding this. Actually this difference is not the difference of distance, this is the difference of time. This is 20th second, this is the 30th second. 30 minus 20, 30 minus 20, and 0 minus 20 I have given. So I got that the speed in the backward journey was 2 meter per second. Okay, I hope that you have understood.